Hello, and welcome to another one of my recordings. Through this recording, I'm going to cover some of the concepts covered in Chapter 8 of your book on arrays and strings. Essentially, we're going to be talking about one-dimensional and two-dimensional arrays, and we'll also talk about character arrays or C strings, which will come in handy as you learn more about C++ concepts. Essentially, as far as arrays are concerned, an array is just a regular variable that can store more than one piece of data. So you can think of an array as essentially a collection of data that all are of the same data type. So, if you've looked at Excel, I guess we could go to Excel. This here is an example of an array. What I've highlighted right now, it looks to be an array of 18 elements. Notice that in Excel, our index or row numbers are start at 1 and go up to 18 or whatever. In C++, array index values start at 0. So if I go in here and say, well, I want to store my data or I want to store the name of 4 of my employees or all 4 of my employees, what I'll do is essentially name this array as name, and then this is really the contents of my array. So what we actually are saying here is that we do something like name sub 0. We use the word sub to indicate a subscript equals to Joe. So again, this reads as name sub 0. And let's do that. Now this is an array of strings. In order for me to essentially create this array in my C++ program, I'll just use the word string followed by the name of the array, the name of the variable, followed by the number of elements or the number of items I want to store. Now in C++, these are referred to as static arrays because you have to actually specify the upper size of the array up front. And this can't be a variable, so it has to be either a constant named variable or a constant like that. So essentially, that's what we, when we get to arrays, we have to be able to define the array, which in C++, again, the definition is rather simple. So if I say int test, I have to use lowercase, int test bracket 100. All I'm saying is that I'm creating an array called test that can have up to 100 values. Now again, remember the indexes start at 0 and go up to 99. Then what you want to do is you want to be able to load your data, and then once you've loaded the data, you want to be able to process the data. So what I want to do is essentially, here's what I hard-coded manually what we wanted this array to have. I can also ask the user to input value for the array, or I can essentially initialize the array when I define it. So remember that the main things you do to an array again is you define arrays, you load data into the arrays, and then you process them. And all one-dimensional arrays, these are called one-dimensional arrays because really all you have is just one dimension or one column of data. We'll also talk about two-dimensional arrays in a few minutes. But so that's really it. You can use arrays with functions. So you could create functions that allow you to get the contents of the array, or to process them, or to whatever you want to do with them. And of course, because you have more than one element to deal with, and these elements are all sequential, they start at 0, then 1, 2, and 3, and so on, a for loop is ideal to process one-dimensional arrays. So let's go back to our, so this is what we mean. I could say data type followed by array name. So I said int, test scores, bracket, and then an integer expression. Again, a constant or a named constant. So array starts at 0. This is what they look like. So list, if I say int list 10, you have 0 through 9. When I say list of 5 equal 34, all I do is put 34 in that array element. So the stuff we could do, the things we can do with arrays is that we can, you can assign values like this, and you can either even use them in expressions like that. You can use essentially an array element in exactly the same way as you read or process a scalar data type, a non-array data type. So the only thing you have to be careful about is that you can't refer to the name of the array by itself. And we'll see that there are some things that are allowed in C++ and some things that are not allowed when you essentially deal with arrays. But these are perfectly fine to refer to individual array elements and then perform operations on them. So basic operations on a one-dimensional array is you can initialize it, you can input data, you can output data that's stored in the array, you can find the largest or smallest element of the array, you can sort the array, you can display them however you want. I mean, again, the type of things you can do with arrays, of course, is endless. And we always use a for loop to pull that off. So when you say int list 100, the array size is now defined to be 100. Int I is just a regular scalar data type. In other words, I can only hold one value, whereas list can hold 100 values. And again, you can do cin list sub I. Now notice with cin and cout, you can't just say cin list. In other words, if you skip the I process, you will get run into errors that you probably wouldn't want. So input and output always requires a loop because you have to refer to specific elements of an array. Now, of course, the array size is always between 0 and 1 minus that because we're starting at 0. So the range of the array index for this array is going to be 0 to 99. And there's no guard against indices that are out of bounds. So if you go out of bounds of an array, if you're inputting or outputting, you're just going to get junk. Sometimes you may even crash your system. So unlike Java, which is strictly forced, the array out of bounds are strictly enforced. C++ does not, and there is no safeguard, so you have to be careful not to run over the size of your array. Notice you can also initialize your arrays like this. You can say double the name of the variable, and don't put anything inside the bracket. And then using a pair of braces, in this case, essentially specify the size, the contents of the array. This is kind of nice if you wanted to do quick and dirty checks on processing arrays. Instead of asking the user to input all these values, you may as well, to begin with, you may just initialize it like that. And what this does is it initializes this array with 1, 2, 3, 4, 4, and 5. So the size of this array is essentially specified by the number of items in the list. So this array will have 5 elements or 5, distinct values in this case. So if you say int list bracket 10 equal to 0, what it will do is it will just assign everything to zeros. So that's a good way to initialize your arrays. If you say int list bracket 10 equals 8, 5, and 12, well, it's just going to give you 8, 5, and 12 in 0, 1, and 2 indices, and the rest will be 0. Okay, so aggregate operations, any operation that manipulates the entire array as a single unit is not allowed on arrays in C++. So you can't say your list equals to my list, because you can't essentially use the equal sign, the assignment operator with arrays like this. You also can't compare two arrays using the equal operator. The solution, again, is that if you want to make a copy of an array, is just use a loop to process the array like that. Arrays are passed by reference to functions. So essentially, if you want to write a function to do something with your arrays, all you have to do is pass the name of the array to the function. You don't need the ampersand symbol that we use to essentially pass by reference for scalar variables. Arrays are passed by reference only, so then you don't have to worry about so changes you make to an array inside a function will take place outside of the function because they're passed by reference. Now, sometimes you definitely don't want your function to change the content of an array. Then you just use the const keyword, and in that case, if you inadvertently try to change the value of y, you will get a compiler error, which is a good thing. That way, you're making sure that you're not violating your own rules. So essentially, we just pass the base address of an array. C++ does not allow functions to return a value of type array. So you can't say return an array type. Again, the return is done through the parameter list of your functions. C++ allows any integral type to be used as an array index. We could use enumerations, but I guess we could skip this because I told you don't really have to worry about this. Type defs is another thing that you don't have to worry about that. Searching an array. So we have different types or different algorithms that we could use to search an array. But essentially, if I had these names, Joe, Bill, Mary, and say Nancy, and I wanted to see if Bill exists or somebody exists in this list, all I have to do is for a sequential search is to start from the beginning of the loop and then compare each element of the array with that search key that we want to find. And if we find a match, then we'll tell the user that we found it. If we don't, then we tell the user that we don't. I'm hoping that you can easily find an algorithm like that on the web, or of course we'll discuss this in class. If it's an online class, of course, you'll have to ask me if you're not sure how to do that. Okay, so that's some of the things we can do with arrays. There's sorting that you can perform on arrays. So selection sort is a good method. And here's an algorithm. Given this algorithm, we should be able to sort the contents of an array in any order we want. So your book actually talks about this selection sort, which is good. Okay, so let's go ahead and bring up some examples. I just wanted to see, we'll go through this stuff together. And as a matter of fact, we'll talk about these functions later. So notice I have const int s equals to 10, int xs. All I'm saying is that create an array with 10 elements and make them all equal to minus 111. Okay? So if I do cout x sub 1, I'm going to display obviously minus 111 because they're all the same as minus 111. And as you might expect, notice I'm trying to do cout x. In other words, I'm trying to say display the contents of the array, and I'm just going to show you what happens because you're just going to get unexpected results. This is what you're going to get for the contents of the array. 0x, essentially the base address of the array. So that's why you don't want to do things like this, don't use cout with the whole array. Okay. Notice here I've created an array with 3 elements. I'm asking the user to enter the test scores, and then I'm just using cin to grab the data. Notice again, we're just using loops to process. Here's a loop to read the data, and here's a loop to display the data. Now, here's a loop that calculates the total of the data. Now, notice right here, I'm creating a function called getTotal. I'm going to give it, to get total, I'm going to give it the array and the number of items. Now, as you might expect, that's what I wanted to show you. The prototype for this should be something that returns maybe a double, and it accepts two parameters. So take a look at this: double, get total, int bracket, and then int. And then if you actually went ahead and looked at the implementation of the function, same thing, except here we have to specify the variable names, and the loop is exactly the same. We just return the total. So I hope you can study this and ask questions if you have it, but I don't want to spend too much time on this. But that's how we send variable arrays to functions. Now remember, if you make any changes to this test array in here, all those changes will be reflected outside of the main function, which probably isn't what you want to do, but you can add a constant keyword to protect that array. All right, now the next thing that your book talks about is this concept of C strings. Now, in the old days, I guess with the beginning with the beginning standards, we didn't actually have this string data type that made our lives a lot easier. Instead, we used to implement arrays or array of characters as a character array. So essentially, when we say string, so right here, when I say, do I have anything right here? String str1 equals hello. Well, all we're saying is str1 is nothing but these 5 characters. In other words, it's an array of characters. And then just because it's an array, every one of these has a position that starts at position 0 and goes up to the last position, in this case, position 4. Now notice for a character array, we use char as our data type, the name of our variable, and we initialize it like this. So now there's a very distinct difference between code and str1. So and I hope you can understand the difference is that this is a special data type called string, and code is nothing but an array of 4 characters. Now, one thing you'll notice that C strings have to be null terminated. So even though we don't see it, there's always a /0 at the end of a C string, which signifies essentially to the compiler that C string will terminate. So notice the tick A is a character A, double quote A is a string A, but the C string A, went too far, essentially represents A followed by /0, which is our null termination character. So, and the reason your book brings this up is that because it is important in cases to be able to use arrays of characters instead of strings, except when you're using compilers that don't support strings. Okay, so when we say char name 16, we're saying that we're creating an array of characters named name that can hold 15 characters. Remember, the last character is reserved for the null termination, or the null character. So when we say char name equals to John, we're creating an array called John. Notice the length is 5 because you have 4 characters for John and 1 for the null character. Now with C strings, we can actually use special functions like string copy, string compare, and string length to actually get, to copy strings or C strings, compare C strings, or get the length of C strings. Okay, so comparison of strings is exactly the same. We always compare character by character. Again, we did talk about strings in this class, so hopefully some of this stuff is already familiar to you. In order to read and write C strings, most rules for arrays also apply to C strings because there are nothing but arrays of characters. So aggregate operations such as assignment and comparison are not allowed. So you can't assign two arrays of characters as we saw before. You can't compare them. That's why we have to use the string compare to compare two strings, for example. Now C++ allows aggregate operations for the input and output, so you can actually use cin and cout to work on C strings. So that's one of these things that you have to put in the back of your mind and be aware of that. Okay. So for example, when we say cin name, now remember name is an array of characters, we're going to only read up to the first white space character. So you got to be careful again with the way we read strings. We had to also worry about, remember with strings we use the getLine function to read an entire string. With C strings we have to use the get function. And the way it works is cin.get, the name of the variable, in this case maybe name, followed by m+1. Now, so if I say 80 here, it's going to read 79 characters, and it's going to hold one space again for its null termination. So, and string output, of course, we do cout with name. Now, again, if you go over the bounds of the string, or if string a C string is not null terminated, you're just going to see garbage printed out if you use a cout with a C string. Okay, so let me see if I have any examples. So notice right here, I have string str1 is hello, string str2 is also hello. So the strings could be compared using the colon, using the two equal sign without a problem. But these two character strings or C strings, CHA1 and CHA2, we can't use the equal. They're just not going to compare, because you're not comparing what's in the strings. You're just comparing the memory addresses, which are not going to be the same. So in this case, you're not going to get a match because you can't compare two strings or two C strings using the equal operator. Instead, you use this string compare thing that gives you 0 if the strings are the same. So when you get a chance, of course, you get this file. So I want you to run through this and make sure that you understand how these things work. And of course, you can make changes. And if you're in doubt, you always ask questions. Okay? So here's, I'm saying enter a string of characters, char C string, or I just called it CSTR. And again, remember, I can use cin because of the fact that you could use cin and cout on C strings. Now, one thing I wanted to bring up here is that remember that we work with file names, and if we're going to ask the user for the name of a file, right now, if I say string fname and then comment out this line, under dev C++, if I compile this, it's going to die right there because the open function of this OF stream requires a C string. So notice if I run this, I'm going to get an error message saying, well, I can't accept this. And remember, we said the fix was to convert this to a C string. Now, as soon as I do this, then my compiler isn't going to bug me, and it's going to compile and run just fine. So if you don't want to use the C string business, then we can just, instead of making our file name a string, we can make our file name a character array. Notice now my compiler is going to be just fine as far as compiling, because fname is an array of characters or a C string, and that's what it requires. So if I compile it, it's going to work just fine. So, a few weeks ago, I asked you to make your file names a string and then use the .c_string function or str function to convert it. Now that you know about the array of characters, you could just use your file names as an array of characters. Okay. By the way, when you read this again, read about this also. Make sure you test your code to make sure that you can read a whole string. So if you have spaces in your strings, you should be able to read them. Okay. So that's that. Let's move on. I'm going to go ahead and skip some of these because you already see that. Parallel arrays are essentially actually, I think there's a good example right here. Here you have student IDs corresponding with the letter grades they get. We call those parallel arrays because the data goes together. So if I go here and if I decide to create another array for like age of these friends that I have, then I could do that. I could just copy that. So and then say, well, Joe is 20 and Bill is 30. Etc. Now, by the way, again, remember that an array in C can only hold data of the same type. So you can't mix strings and characters and numbers together. Okay? So 35 and 18. Okay? So we call name and age parallel arrays because they go together, essentially. Okay? Now, we also in C++ can do multi-dimensional arrays. Now, in this class, we're just going to talk about the two-dimensional array, because really that's all you need. But you can handle any other dimensions if you want. And a two-dimensional array looks exactly like a table. So if I insert a table like this, there you go. So here's a two-dimensional array. Now, remember, a table has rows and columns. Same idea. Now, the data in here will essentially represent some real-life situation. For example, I could have, maybe test scores, 70, 82, 90 for my first student. And then my second student got an 85, 100, and 100, right? So notice the data is all integers or doubles or whatever. But what we have is the rows start at 0, 1, 2, 3, and then columns go 0, 1, 2, in this case 0, 1, and 2. Excel is an ideal thing to look at as a two-dimensional array. Notice in this case the columns have A, B, C, D, letters, and the numbers for the rows. Of course, in C++ we can't really use these as array indices because array indices are always whole numbers. So we say this is 0, 1, 2. This is 0, 1, 2. So really, this would be row 0, 1, 2, and this is column 0 and 1. So this will be 0, comma 1, comma 1. So that's the cell number 0, comma 1. I think your book has a better picture of this, so go just like this. So sales essentially have rows. Rows go this way, horizontal, and columns are vertical. And you can think about this as maybe sales on a daily basis by different people. And notice how this is sales 5, 3, because that's row 5, and that's column 3. Now, in order to define an array in a two-dimensional array, same idea. You have the array name followed by 2 indices now. So when I go to my example here, I have a football game, which is an integer, and I have 2 dimensions, and I can initialize it like this. So this could be the results of a football game. And again, I put these white spaces in there. I put the return there just for readability. They could just be all on one line. And with two-dimensional arrays, the only thing that the only dimension that you can leave blank, I mean, you could put 2 in there, but you don't have to. But the only thing that you could leave blank is the first one. So any subsequent index, if you have a 3-dimensional array, everything has to have a size. So when you see this int football game, this actually has 2 rows and 4 columns. You could think about this as a football game between 2 teams and 4 quarters. So if I were going to do that in my Excel, or let's just do it in Word, I will insert something a table that has 2 rows and 4 columns. So this 10 will essentially represent team 1 and quarter 1, and so on. So when I go back, this hopefully should make sense that it looks like team 1 scored 7 points. Team 1 scored 10 points in the second quarter, third quarter, and fourth quarter. Same thing for that. Now, in order to process two-dimensional arrays, same idea as one-dimensional arrays, you must use 2 loops. So notice I have a loop. Let's say I want to find the total for each team. Well, I have an outer array that processes the rows that I have, and then I have an inner array or inner loop that processes all the quarters. So notice here team is 0, so I'm starting at the first team, and then for that team I'm going through the quarters and accumulating the totals for the team. So when I come back, I will and then I do a cout to grab the data for the team. So notice if I run this thing, I'm going to skip some of these inputs that this thing is going to ask me. So I'm just going to get to a place where it's going to show you. So it says, notice team 1 scored 20 points. Team 2 scores 17 points. That's because of that, because of the output that I have. Notice I can also ask the user to give me the results of the football game. Again, cin, and then the array name followed by the 2 indices. Again, if this was a 3-dimensional array, you're going to have 3 loops. So this thing is going to wait for me. Right now it's waiting for me to input test scores, or in this case, football scores. So I'm going to say, well, 10 points for the first team, for the first quarter, second quarter, third quarter, and 0 for the last quarter. The second team scored 12 points, and 5 points, and 7 points, and 1 point. And it's going to tell you that, well, here's your output, 10, 3, 0, 0, 12, 5, 7, 1. Again, notice I used a cout statement to print out the content of the two-dimensional array. I'm also showing you how to actually write a function, in this case named display, where I pass it the name of the array and it will print it for me. So again, as you might have expected, the function is void because it's not returning a value. So if you look at the header for this, it's going to be void display int football game. And then, of course, remember the name of these 2 things don't have to be the same. Most of the times they're not, because this really could have been a specific football game that I'm trying to, display. This is exactly the same loop as we just discussed. And you may want to pass some variables for the size of these things, but the footballs, I guess, is always 2 quarters, 2 teams and 4 quarters, so you can always assume 2 and 4. Again, remember, anytime you see a constant, you should be able to replace it with a variable, and in most cases you should. So for something like this, I will say const, I create a constant called number of teams, make it 2, a constant named number of quarters, make it 4, and then use those constants throughout my program. So again, the prototype for this would be void display int I don't need a name, so just be a open bracket, close bracket, and then open bracket. Remember, I need to have an index or a value for the last index. So if I go up, here it is, 4. I guess I don't need that space there. Okay, so I'll go ahead and stop here. I hope this is helpful. Again, you should read the concept of arrays, which is really important in programming, because you're allowed to essentially collect a whole bunch of data at one time and operate on a whole bunch of data at one time. Okay, I will stop right now. Have a good day or good night, I guess, depending on when you're viewing this. Goodbye.